right, welcome to this podcast. Today we're going to be looking at sets and counting, specifically involving the multiplication rule. Now we're going to do this from a set perspective. There's going to be a couple of videos coming up where we're going to look at multiplication rule from a sort of different perspective. But in terms of sets, if you're talking about multiplication rule, the main thing you need to be aware of is the following set operation. And you might think that you would read this as A times B, but in fact, the better way to read this mathematically is A cross B. In other words, we're thinking of matching the things from A with the things from B, and in mathematics we typically call that a cross operator. In terms of set notation, the set builder notation for this set is the set of all things that are coordinate pairs, so you're pairing up the things that come from A with the things that come from B. And in fact, this set has a name. It's called the Cartesian product. Now, it's not such a big deal that you remember the name necessarily, but the reason that this set is important is because of the following rule. If set A has size given by little a, and set B has size given by little b, then if you look at the size of A cross B, or the Cartesian product of A with B, that set has size little a times little b. This is called the multiplication rule. All right, the multiplication rule is actually a fairly easy rule to understand. Let me illustrate with a small little example to get us started. If you look at the set A, let's suppose it contains two elements, A and B. And we'll look at the set B as well, and we'll say it contains the elements U and V. Then if we go to try to form the set A cross B, what are the elements of that set? Well, the first element is A paired with U, and then you could have A paired with V. Next is B paired with U, and B paired with V. So you do see, in fact, that the multiplication rule holds here. There's two elements in A, two elements in B, and so there should be 2 times 2, or 4 elements in A cross B. That's not why I wanted to do this example with you. I wanted to do this example with you to remind you that this multiplication rule is very much like another thing that you've gotten used to over the years, and that's FOIL. If you think about how you used to FOIL, you used to take what were called binomials, something like A plus B, and multiply it by something times U plus V. So what the FOIL was doing was matching up all the different pieces, which is exactly what the Cartesian product does. So remember, the FOIL in this case would have matched the first terms, A and U, the outside terms, A and V, the inside terms, B and U, and the last terms, B and V. Notice that these two things match up completely. So this is really no different than, I don't want to say different than the FOIL operation, but it's the same sort of idea as what FOIL was. Let's illustrate this with an example. In this particular example, I want to put together a schedule, and here are the following courses that I can take for the schedule. We get to pick from having, let's say, 3 English courses. We'll also do, let's say, 4 math courses I could potentially take. Maybe there's 2 history courses I like, and 5 Bible, and 2 science. So I have a lot of different options for the courses I can take, but what I need to do is I need to pick one out of each piece. Now, in terms of our sets, we'll think of English as being set A, math as being the set B, set C will be history, D will be Bible, and so on. So the question I'm essentially asking at this point is how many schedules are possible? Well, a schedule consists of matching up A, B, C, D, and E by choosing one from each of those sets. So what I'm really asking you here is how many things are in the set A cross B, cross C, cross D, cross E. Well, according to the multiplication rule, that's simply 3 times 4 times 2 times 5 times 2 for a total of 240 possible schedules. Well, that doesn't really, that tells us how many possible schedules we have. If we were interested in a particular schedule, we might want to look at an element of such a set. And a typical element would look something like the following. We could have, let's see here. You might choose, let's say, English 101 and Math 120, maybe History 212, Introductory Bible course, say BIBL 101, and maybe a chemistry course for your science. So there would be an element of that set. That element would have 5 different pieces to it, but it belongs to this much larger set that's the product of all 5 of those sets. Right, this is generally speaking how you handle multiplication rule. It's simply nothing more than a multiplication of the number of elements in each set paired up in as many ways as possible. All right, thank you for watching this podcast. In the future podcasts, we're going to be learning to take multiplication rule now that we've learned a little bit about it and apply it to a wider variety of problems.